Awesome, thank you. Thank you so much. Thanks for joining. I usually do a bit of a survey in the beginning. So the data set's going to be a little bit smaller now than usual, but thanks for joining regardless. How many of you guys are aware or have heard about Avail? All right, that's an answer. Perfect, thank you. And how many of you are aware of the data availability problem as a whole in the space? Cool. Awesome. Thank you so much. Yeah. This talk will be about a product that we've been building for the past 3.5 years. We started as part of Polygon, as a team inside of Polygon. I think it's 3.5 years, but yeah, I don't remember things very well, so that's where we are. We then changed the structure, or exited Polygon in a way. Now we're a separate entity, building separately because that's what made the most sense. And I'll go through the challenges of the current space. I'll go through the problem statement itself, high-level view, and then I'll go through some technical bits of the products that we've built. I'll mainly focus on the most immediate product that we're launching this half 2024 on mainnet, but it's been running on testnet for quite a while now. Cool. So the problem statement right now, there's been a lot of roll-ups popping up in the space in the past year, more than a year, but it's been something that's been ramping up quite a bit. So they've been used as a way to scale blockchains, and one of the things that they need is data availability. So they need somewhere to post or publish data, and then there needs to be some kind of a verification that the data has indeed been published. One of the issues that I'll go into with this approach is that if you have a lot of rollups, you end up with a lot of fragmentation in the space, because by default there's no composability between the rollups, so you end up with the same problem as if you had hundreds, thousands of chains. And then if you're someone who needs to build an application that, for example, communicates with a bunch of rollups, you end up with a bit of an issue. If there's no composability, you end up having to look for a solution that pretty much ends up being something like a couple of bridges linking all the rollups. So there's some sense of unification that is required. Usually nowadays, if you look around, most of the rollups are Ethereum based or have taken sort of the most attention, at least. That is, rollups in a way are the main way of having off-chain computation. And the growth of rollups created a lot of demand for Ethereum for data availability, or on Ethereum for data availability. But if you look at the roadmap of Ethereum, full dank sharding is still a long time off by the looks of it. And that's why we started building a solution that I'll be talking about today. It's called Avail DA. It's powered by zero-knowledge proofs and KZG polynomial commitments for validity proofs. And the end goal is to improve the user experience across the whole space. So right now, if you look at the space, there's hundreds of general purpose and specific rollups that are popping up. It's probably thousands or even more, perhaps. And like I said, this is leading to some sense of fragmentation across the space. And we, in general, across Web3, we haven't been very good at building something that allows for the creation of a good user experience. If you look at the past, 10 years of this space, so we always have to, we create something, we create a solution for something, and only after that we start thinking about the actual, what does the UX look like? How is this thing easy to use or not easy to use, and so on and so forth. So in a way to address this fragmentations or fragmentation, rollups should be able to interoperate in a trust minimized way, ideally. And that's where our product that I'll be talking about very briefly comes in, Avail Nexus, which will be unifying the rollups across Web3 with proof aggregation and data availability sampling. I'll go into that in a bit. But at the same time, if you create a solution for something, that usually needs a solution for that as well, in a way. So creating that kind of coordination of value across blockchains also requires some shared economic security in the unification layer or for the unification layer. And that's where the third product that I'll be talking about comes in, and that's Avail Fusion security. So we have three things that we're building: Avail DA, Avail Nexus, and Avail Fusion. I will spend the most time on Avail DA. So Avail DA, like I mentioned, is something we've been building for 3.5 years now. It's a validity proof-based data availability layer. So it's something that allows you to utilize data availability block space and post data via light client and utilize something that we call data availability sampling if you're a rollup. And we've built it in a way that allows for easy verifiability using KZG polynomial commitments. So that's kind of how we've built it to make it as easy as possible for anyone to not have to run a node, but instead run a very lightweight light client that allows you to actually verify that the data has been published. I'll go into that in a second. Avail DA is a modular base layer that provides unopinionated block space to modular chains. What it does is sequences, packages, and publishes data. It also segregates the transaction data based on something that we call app IDs. So you post data for your application, for your rollup, and then you also retrieve data for your application and your rollup. You don't have to care about the other data that's being posted or that's being stored. It's a Avail DA, in a way, is built on a substrate SDK, or right now you can also call it Polka.SDK, I guess. It has a robust validator set that will sign off on the published blocks. And like I said, it's completely oblivious to the transaction data contained in the blocks. And and then each rollup that uses Avail data availability then can define the way that it actually does the computation. So it can be an EVM bytecode, it can be something very specific. It doesn't have to be a VM at all as well. All right, I'll go very briefly through the node network. It's probably more detail than needed. So like I mentioned, we built it on Substrate. And this gave us the flexibility to develop this further, do things like, have block size that we can work with in the future, have a very proven solution, for example, used by a lot of chains like Polkadot, Kusama, and so on and so forth. So built on that SDK, so that we don't have to reinvent the wheel, because right now that's not something that's really worth doing. We use Babe and Grandpa for block offering and finality. These have also been things that have been battle proven in the space quite a bit. We have pretty fast finality, fastest across the DA solutions, and like I mentioned, Substrate being pretty resilient, even if there's a large network partition and so on and so forth. So we really just wanted to make sure that the base layer is as robust as possible so that we can focus on the actual solutions on top. All right, some of the Substrate changes that we've made a 20-second block time instead of a 6-second block time, which is standard Substrate SDK. We did that to give enough time for the light client network to be able to actually process what's in the block and put it into a distributed hash table that I'll go into in a bit as well. Like I mentioned, there's a concept of application ID, which segregates the data based on the poster and the application as a whole. And then that's kind of what it looks like. You post data, you have a signature for the app ID, and that's how you like recognize that it's your data and what you're gonna fetch afterwards when you need it. We also extended the substrate header, so we have modified the system and executive palettes, and we added an extension to the blocks, so it contains all the information that is required to support the data availability that we're using substrate for. There's a header and an extension to it. All right, I'll go through the whole flow. So applications send some data blobs to Avail using an arbitrary application ID. Let's say it's an application 1 in here, application 2, application 3, or application 1 actually, but it's a post number 3. And then what we actually do is order the data, chunk it, and then pad it if there's still some room left. What we then do, we take that data, we generate commitments for that data, and then we do erasure coding on those commitments, or with those commitments. And we create something that we call extended commitments that we then pass into the extended header for each block. And we create like a matrix that is dynamic in size, and then yeah, that allows us to make sure that we save on computation, we don't extend the header unnecessarily, and so on and so forth. And all it contains basically is a data root, matrix size, application index, and the commitments. Yeah. Then we post that data or propagate that data to the network. The block is then propagated to the network. And yeah, we also made some changes to the import-export or the import mechanism and the comparison of the imported header with the generated header so that they're actually the same. And we've extended substrate with some RPCs that are created just for this application to allow for the data availability scenarios and our light client scenarios to be supported. So you can do sampling, they integrate other custom features that we need for light clients, they can be queried by light clients or by anyone else, and they're cached. So I'll go through data availability sampling and how that works in a little bit. And now I'll focus more on the light client network, which technically, if you look at the Avail DA, it's like 2 networks on top. One is the base layer network with the substrate nodes, and there's the light client network that is separate. All right, so how did it actually work? It's something that we built using Rust with things like Rust lib peer-to-peer. It's an overlay peer-to-peer network on the base layer, like I mentioned. It's the main sort of way to query the network and verify data availability and things like that for finalized blocks. And it performs also data availability sampling for each block. They do not need to download the block content. That is due to the way that we create the commitments and then do erasure coding. You only need to sample parts of the block. And they maintain a Kademlia-based distributed hash table. So that creates another network. So eventually they're not dependent as much on the nodes. They're just dependent on one another to be able to verify that data has been published. All right, and you only need a couple of samples or several samples to give you guarantees close to 100% of that something's been published. All right, I'll go through the actual data availability sampling process here briefly. So you have validators, you have a network that publishes 2 blocks. Let's say light client 1 queries the validator network or the node network for the data and the extended header with the commitments. It gets what it wants, and then it populates a block replica on the DHT, on the distributed hash table. So let's say it has some coverage of like 25% or something like that. Then another light client does the same for different kind of data. For example, it has a different application ID or something like that. And it populates the DHT with more data. And then another light client comes in. It's like, yeah, I'm not going to query the node network for this. I'm just going to see if it's already on the DHT. And it finds out it's not. So it falls back to actually querying the nodes. And it gets all that it needs for the scenario that it's trying to accomplish. And it populates the rest of the DHT. And now in the DHT, we actually have all the blocks on the network covered. So all the upcoming light clients, they don't really need to query the nodes, let's say, in a simplistic way. They just go directly through the DHT. All right, and yeah, just very briefly, we spend most of the time actually optimizing the peer-to-peer network because the way lib peer-to-peer right now works, it's very dependent on the scenarios that you're doing. And there's other concepts like fat clients that actually sample more parts of the block, but it's not that relevant as there's only going to be a couple of them usually, but they have more of a coverage and they can like provide more data to others and so on and so forth. And when we sample finalized blocks, if we get a header but a node has invalid data, the samplers won't match the commitments because we actually sample just the finalized blocks, so then it gets like thrown away. All right, what's next? I'll just very briefly go through the last 2 bits of Avail Nexus and Avail Fusion. And these kind of extend the base solution that I just talked about that provides the base data availability sampling. And like I mentioned in the beginning, if you have a lot of rollups and you want to work with a couple rollups for your application or something like that, or let's say you want to have some composability between all of the rollups, you end up with a solution that would resemble, for example, something like thousands of bridges, if you wanted to connect all the rollups in some meaningful way and then work with whatever they produce. Which is not really sustainable if you look at the way Web3 works right now. Bridges are usually the weakest link in the solutions, so you kind of want to avoid having bridges for everything. That's when something that can act as a middleware comes in, and we're developing something that we call Nexus that acts as a unification layer. And yeah, it acts as like a verification hub that unifies the rollups using Avail DA as the root of the trust, the base layer. And that way we want to enable like unified experiences so that you can then actually use what comes out of the Nexus and use that to achieve composability between all the rollups that are using that solution. So you don't need to understand or know anything about the state transition function of the other rollups. You only verify that the transition functions were completed correctly, and the Avail Nexus does a proof composition, and you only have to verify a single proof, and that allows you to verify the validity of all executions on all the rollups that have happened before. So it pretty much takes proofs from the different rollups that are either posted directly to the Nexus layer or to the data availability layer, and then it creates one singular proof for all of them in a way. And another thing that it does is a transaction sequencing inclusion. So it's or at least the coordination via a decentralized sequencer selection mechanism will be also done by Avail Nexus. All right, and then Avail Fusion. Like I mentioned, you create a solution for something that needs another solution. So once you have something like a unified layer like this, you also need something like a unified security for all of that. So you need to make sure that if you have a unified layer like this, you also need to make sure that it's extremely secure to make sure all the crypto economic guarantees are there and so on and so forth. And with ML Fusion, this is actually something we're targeting 2025 for, or with, you can actually add crypto economic security to the base layer by actually adding or staking other different assets like, VTC, Ethereum, different tokens for coming from different rollups and so on and so forth. And all of that together combined creates like a increased joint security structure. So, and it like contributes to the consensus alongside, alongside all the other tokens that are represented on the shared layer. Cool, that is pretty much it. I'm not sure if there are any questions or anything like that, but thanks for being here.